Hi, Joyce.
Hey, Joyce. How you doing?
I said it first this time.
Hey Joyce, we started off with this in the back of our spiral, so go ahead and try them all. 2 of them are homework, so it's basically just thinking of what answers you got, and then we're going to check them. So go ahead and pause, try, and then come back.
Oh, can I say welcome back? We're back, Joyce.
Welcome back. All right, so number 47.
We're back.
Which of the following values is the absolute maximum? How do you guys determine the absolute maximum?
Find
We
the
gotta find critical numbers.
And when you found f prime and you set them equal to 0, what did you figure out as your zeros? X
2.
equals
Two.
just 2?
Just
Yeah.
two.
Just 2.
And then we gotta make a sign chart to see if it is a max.
Do we actually assign chart if it's just a
No.
polynomial, or can we just test our candidates?
Just
Well, we
they
need
tell
to
us
see if
they tell us
a
it's a max, so critical max can only really occur at a critical number. So I just put it in.
And no, it goes to be a min.
True, but if it's a polynomial, so it's a continuous function, do we really need to do a sign chart to see how it's moving, or can we just test the candidates?
Just
0, 2, 4. Does that make sense, my question?
I guess.
Okay. Then plugging in 0, what did you guys get?
I got 6.
6. Plugging in 2, what'd you get?
I got
10.
well,
Oh, I don't know, I got 10 and 12, who's right?
I forgot how to count, so I don't know. Well, 8 minus
Yeah, it's 10.
4. Yeah, it's 10.
Yeah. Then plugging in 4, we end up with 16 minus 16 plus 6. 6 again, right? So where's our absolute max?
Still 2.
Still 2.
10.
Miss D,
Yes.
they tell us that. Oh wait,
I think it should be E.
no, because they tell us it's max.
That doesn't really make a difference. However, question, why is Jackie right? And the answer is E instead of B.
Because they want the value.
They don't say at, they say value. So
Oh,
what is
no.
that?
Those savages.
You know them, you know they
First
do
try.
this.
Right.
Those dirty savages.
Value, they want the 10, which happens at the 2.
I didn't even see circle B.
Okay. Number 48.
E.
I got,
I got E.
let's see.
Okay.
Because
If f is a continuous, decreasing function on
Oh,
0 to
it
10 with a
must.
critical point at 4, 2, which of the following must be false?
I
because
don't know.
f prime of 4 could be true.
That's the description of decreasing, right?
Oh,
Yeah.
So must be false.
D.
4 is in between 0 to 10, so it better be decreasing because it's decreasing. So that's not it. D,
Oh.
f prime of 4 equals 0.
It's a critical
it's
number.
a critical number. So that could be
That
true.
could be true.
C
Same
could
thing
be
as
true.
C, because remember, we know it's either D and E or 0. Do we know for sure which one's which? No, because we didn't say differentiable, so we can't, if it's a differentiable, we cross off that one. But no, some, or either of those could be true.
Then it
F of
has
4
to
is
be B.
neither a relative maximum nor a relative minimum.
That's it, I think, because it's not A, it's A.
It is neither a relative maximum nor a relative minimum. Question, how can it be a relative max or a relative min if the function is only decreasing?
That's what I was saying.
But
It
does
has
have
to
be-
change from increasing to decreasing for one of them. Doesn't have to be rounded, but it does have to change. In the interior, at the endpoints, maybe it cuts off at a higher
Is
low.
false?
How is A false?
If it's decreasing all the way to 10,
Because decreasing to 10,
then 10 has to be the minimum.
Yeah, what the heck? They lied to us.
So what's going on? What did we miss?
I still think that it could be E because f prime of 4 has to be 0 or D and E for it to be a critical point. Can't be negative.
Power 4, if we're doing a sign chart,
Can C, D, and E all be true?
No.
It can't be 0 or D and E or negative, right?
Ooh.
Critical point defines, or is defined by the derivative either being 0 or D and E. So even though 4 is in the interior of 0 to 10, Gerardo is right.
Yes.
I don't need a negative at 4 in order, it can't be negative. The derivative can't be negative because it has to be 0 or D and E, or else it will not be a critical point.
Did you trick us on purpose?
Oh, maybe. Number 49.
I hate the answers.
Which of the following functions has exactly 2 local extrema in its domain?
B.
B. You guys sure?
That's what it says in the back of the book.
That's easy.
Wait,
Number
how are you supposed to
50.
do that so fast?
You just gotta know, you know that A doesn't
You mean number
have
49 or number 50?
49, because I was sitting at my desk and I was just like, how am I
Well,
supposed to do this in a minute?
an absolute value
No.
function is only gonna have one extreme,
One.
and it can't possibly change.
B
Tangent of x
or B.
can't have, doesn't have any local extreme, actually, in its domain. X plus ln of x, that's a little bit trickier, but x, well, he just keeps going forever, ln of x, neither of them individually have absolute extrema. If you were to take the derivative, you'd have 1 plus 1 over x, which is the same thing as x plus 1 over x, you'd have negative 1 or 0. So I would say you're probably between these three. But negative 1 doesn't work with ln, so it's not in the domain, so I only have one critical number, so that's not gonna work. I'm between my two cubics, we just need to figure out which one.
Wait. Can't opposite infinities be max or min?
No,
Why?
because it keep going on and on and on forever, there's no maximum number.
But the critical numbers of the derivative, Gerardo, would be negative 1 and 0. Negative 1's not in the original domain.
No, I'm talking about tangent x.
Tangent of x doesn't have any relative extreme in its domain. Yeah, so there's no relative extreme. There's no point that is higher than all the points around it.
Okay, if the function is continuous and the derivative has opposite infinities, you know that it's a cusp. So that means that if it's going decreasing to increasing, then you know that the cusp is a minimum, right?
A minimum of the derivative, but not a minimum of the original, bud.
Why wouldn't the cusp be a minimum of the derivative? I mean, of the original.
It doesn't exist for letter E. Oh, you're still at tangent?
No, I'm at a different question. This is a whole different question.
Okay, then let's do number
Yeah,
50,
yeah,
we'll
yeah.
come back to it.
I'm
Number
sorry.
50, if an even function f with a domain of all real numbers has a local max at x equals a, then f of negative a equals. Even functions means that f of negative a equals f of a. Plugging in a negative x value is the exact same thing as what's going on at the positive x value, so if it's even, there's a local max at x equals a, there must at negative a also be a local max. We got it? Let's go ahead and quickly check our evens from our homework. And homework that was due today was section 5.2, right?
Part of it.
Mhm.
No, 5-1.
5.2 we started yesterday, we're finishing today, good. So section 5.1, here we go. I'm at 5.2 where we're gonna come back. 5.1, what was our first even? Let me get to the exercises really quickly. Uh-oh, did I already pass it? There it is. Okay, number?
4.
4, he's right here. 4 has a local max at negative 3, 0, local min at 2, 0, maximum at 1, 2, and minimum, which means absolute, right? If they're not saying local or relative, at 0, negative 1. Good?
No. Because 4 was D and E. There was a hole at those points. There was a jump. 4? Oh, I must have looked at the wrong problem then.
Oh, bummer. Okay. It makes sense with the one that you guys looked at. Number next one. No max, no min. Why does it not contradict the extreme value theorem?
Continuous.
It's not continuous or defined on a closed interval.
Yes, I didn't write it.
No max, no min, because there were holes on that one at the highest and lowest or something, right? Number next one.
14.
Check 9?
Max at C and then min at A?
Uh-huh.
Okay, so on that one.
What was your graph? I don't have that memorized. Number 9?
Yeah, so you can say that since it's continuous on A to C, that can have a min and a max,
It's
even
not
though the
continuous on
function
A to
isn't
C.
continuous.
It can still have a min and a max, even if it doesn't, but it's just not guaranteed by the extreme value theorem to have a min and max. So the
Right.
highest is at C and the lowest is at A.
But because we see it on the graph, we have to visually realize min and max.
Right,
Okay. Yeah.
right. Number next one.
14.
First derivative has a 0 at 0, so that would be the critical point. Domain has no endpoints. Testing at 0, we end up with a max. Since k prime is 0 at the only critical point, there are no critical points that are not stationary points. They're saying, okay, the only one was 0, so therefore it is a stationary point, there are none that are not. That's kind of silly. But at 0 you have a max, long story short. Is that good? Okay, number next one.
Okay.
24.
24.
Hopefully you split up the domain at -1 and 1. Y prime was negative 2x over x squared minus 1 quantity squared. You had a horizontal tangent line at x. You had -1 and 1 that you should have included just because they're not in the domain, but they're not candidates. And we end up with
Can I just say x cannot equal?
a local max at 0. You can say x cannot equal 1 and -1, but you have to include that in your analysis to split up your intervals, because who knows what's going on at that -1 and 1 without deeper
Or you have to
analysis.
actually- You have to include -1 and 1 on your sign chart?
In your sign chart, yes, but they're not critical numbers because they're DNEs of the original.
This is kind of what I was asking. Actually, no, this is not what I was asking, never mind.
Okay, number next one.
1 second.
34.
34, yeah, I didn't know that these.
These you have to take, well, but I screwed up on the first one.
I don't know, yeah, 31, 34, I didn't know how to take derivative of an absolute value.
It's,
Didn't they give you-
over
you can use
absolute
your
value of u
calculator for
times
that?
u prime.
Yeah, but that doesn't use a derivative function, it uses a derivative value.
They use the calculator just because technically they didn't introduce the first or second derivative test until section 5.3. But, you could have taken the derivative, remember the derivative of absolute value of u is
U over,
absolute value of u over u times u prime.
I thought it was the other, I thought it was u
Either
over.
way, you can do
That's
either.
why.
You can do it either way, but as soon as you take the derivative, you have a denominator, and that denominator is gonna be at the zeros of each of those absolute values, which would be at, for 31, or no, for 34, -1 and 3. So those were our critical numbers.
Why did I? I'm so dumb.
And they went ahead and stated it was for the entire interval,
What?
which is a bit of a struggle because it's a horizontal line there.
So you have to find, so you have to derive, and then what?
Derive, find the critical numbers.
And the critical numbers, you have two denominators.
Right.
Each one will be what's inside the absolute values, your critical numbers of -1 and 3. And then if you do a sign chart, you would have ended up with negative on the left, 0 in between, positive on the right. Because the middle was a constant function, because the derivative would have been a constant that entire time.
So it was a negative on the left of -1, and then 1 in the middle?
And then it should have been 0 in the middle, right? Because the slope is 0. Would have been 0 all the points in between.
But then we have to test, how do we test that on the sign chart?
Yeah, how do you find
Well,
out?
you would have had your, I mean, absolute value is a piecewise function, so it's a little bit trickier than most, but I would have had my -1 and I would have had my 3, and we would have had our negative and our positive, and then this, if you had kept plugging in, they're all zeros.
So then, wouldn't those be critical numbers too, or well, then they can't be, I don't know.
Wait, how do you find
They're
it?
all critical numbers. Every value from -1.
Did you guys finish finding the derivative? Sorry, I just saw that their denominator is at -1.
It was the absolute value of x plus 1 over x plus 1.
So the absolute value,
Well, plus, don't we have
Plus.
2?
Yeah.
plus
The
x
absolute
minus
value of x
X
plus
minus
1
2.
all over x plus 1
Times 1.
plus
x
Plus.
x minus 3.
Oh,
All
right.
over x minus 3. If we had gotten common denominators, we would have ended up with yuckiness.
They did the same mistake earlier.
That's why I put them on the bottom. Sorry.
Wouldn't you still have had to do? Oh, so you could simplify it better?
Yeah.
That makes sense.
Put what on the bottom?
I
That's
put
the
the
values
absolute
on
values
the
on the bottom, so
It has
I
the
could
exact same
simplify
effect.
the polynomials.
So it could be either or, absolute
Yeah.
value on top or bottom.
Because you just need to preserve the sign, and either one will preserve the sign.
That's what
Oh, but the problem is now we still have to multiply by the absolute values, so you're gonna get the exact same thing.
But don't they can't, oh, we have to do it over and over.
I'm just gonna put it those because I think that's somewhere, right?
Yeah, I definitely messed that up on the
Looks
So
like
when
it-
you plug in -1, you get 0 plus 0 over 0.
The struggle with this one, if you're checking out, if we plug in anything between -1 or 3, say 0. Well, first of all, 0 plus 1, +1, 0 minus 3, +3, +1, +3, there we go. 0 minus 3, -3, 0 plus 1, +1, it's +3, -3, any of those values in between are all gonna make 0. Because of our parentheses, they're gonna be opposite signs, that's basically the long story short.
So you can just say that if it equals 3, or from, if you put in 1 or you put in 3, it's gonna be 0 either way.
If you put in -1, anything in between -1 and 3, they're all gonna be 0. Cause they're all gonna get the exact same value, just one of them's gonna be positive, one of them's gonna be negative.
But if we do it, let's say we didn't know that, we were just doing it normally, would we just find that there's 2 zeros, a -1 and 3?
Well, if you're doing it normally, you wouldn't know how to solve the top without splitting it up into piecewise functions. So you could have your -1 and your 3 from down here, but you wouldn't know how to find the zeros at the top.
Why? How do you find zeros at the top?
Well, I said you wouldn't know how to, you would solve it, and then you would go ahead and, I don't know, subtract to the other side, do some dividing stuff, and have x plus 1 over x minus 3 over here. You have the absolute value of x plus 1 over the absolute value of x minus 3 over there. You would say, hey, they're the exact same thing, except in between -1 and 3, they're gonna be opposite signs, which means when I add them, they're gonna be 0. So it might have been smarter to split this up into piecewise functions. But technically, as you guys can tell, they weren't expecting you to fully solve that one. They're expecting you more to do a graphical exploration.
Oh, so how do we, this would be a graphing section problem.
Probably. I haven't seen anything this complicated on the AP before. Number 36, final answer is critical point 0, 0 is not a stationary point. And we have a local max at 0, the min at -1, and the min also at 1 because they tie.
Absolute max or local? I put local min for x is equal.
It says identify the critical points and determine the local. They didn't actually ask you to determine the absolute, to be honest.
Oh, this is the one I had a question on, actually, because since it comes to a cusp at x equals 0, it goes from increasing to decreasing. So if it's increasing, decreasing, then the cusp is maximum.
Yeah. Whenever you go from increasing to decreasing, it doesn't matter whether it's a cusp or otherwise. If you're going from increasing to decreasing, the original function exists there, and the derivative is 0 or undefined at the in-between, then yes, it's a local max.
But you have to realize that it's continuous there because of the domain, and be like, oh, there must be a cusp because it's. Right?
Well, it doesn't matter about it being a cusp. If you go from increasing to decreasing at a point that exists in f and is a critical number of f, you always have a local max. That's the first derivative test. If you go from increasing to decreasing at a critical point, as long as f is continuous there, it's always a local max.
Thank you.
You're welcome. Now our next one is 40. Is that right?
50.
Oh, 50. I thought I had 40 circled.
So we already did.
Nice. All right, out of here. In our notes, we were talking about MVT, the mean value theorem. We were talking about why it does not apply. We did a somewhat normal function yesterday. He was a little bit funny because square root of x squared is absolute value of x. That was a little tricky to think about. What are we going to do with the piecewise and letter B?
See, I still have questions on it if you want.
Okay, we'll try to address them tomorrow when we have more time. Letter B, remind me at the beginning, or during non-chapter school. Letter B, how do we deal with the piecewise function, cool kids?
Oh, you just do it everything separately.
But first of all, what do we have to test technically before even testing differentiability?
They touch.
Basically, do they meet? Hence, is it continuous? So we check the one-sided limits, basically by plugging in and saying, hey, 1 cubed plus 3 is 4. Does that equal 1 squared plus 1? No. So therefore, I can say? Exactly. F is not continuous at x equals 1. MVT does not apply. Does not mean that the conclusion may not be true, but I am not guaranteed the existence by MVT. Cool?
What?
F is not continuous, so MVT fails.
Where did you get 4 and 2?
Plug it in, plug it in.
Oh my god, I'm not smart.
There you go. Okay, section 5.2 ends in a funny place. Section 5.2 ends in a funny place. It starts talking about this thing called an antiderivative.
Yay.
Antiderivative, those of you from last year. Someone, give me a description.
An antiderivative is taking the derivative going the opposite direction, getting the original function.
Having the derivative and then trying to figure out what was the original function. Yeah, so if we look at this definition that's up here, a function capital F, and that's just our notation, right? Is an antiderivative of a function little f if, here's the key, yeah? Capital F prime equals little f. So what are we given? A function, and what are we trying to find? Whose prime is it? And our book has a very interesting way of doing it. Of introducing it, anyway.
Oh.
Oh, you're still looking.
Yeah.
Hold on.
I was kind of high.
It's okay, give me a sec. There you go. Our book has an interesting way of doing it in that it just kind of basically says something like, hey, which function, basically, has a derivative of, let's think of a function, think of any function whose derivative would be 2x, which is kind of where we started as well, but x squared, yeah. So we can say, oh, hey, x squared should be capital F of x is equal to, we're like, hey, x squared is a derivative of 2x, and that's cool and all, but then we say, uh-oh, but what else could have a derivative of 2x?
X squared plus 1.
X squared plus 1, or x squared minus 1, or x squared plus pi, or x squared plus a million, or x squared plus 17 over e. X squared plus, just to have fun. Ooh. Only if Pink Manny is a constant.
Isn't he?
He's constantly retarded.
Well, that's lame. X squared plus c. However, even though logically, hopefully you guys can understand why there's a plus c in the sense that there could be any constant that's being added to the x squared, that's why we call this actually a family of antiderivatives, plural. Our book goes about, because it's really cool and collegiate like that, to go ahead and show a mathematical proof as to why the plus c is actually necessary. And long story short, in order to show why the plus c is necessary, without just logically explaining it to you and being like, oh yeah, that makes sense. There's some things make sense in math and they're actually not true. So you have to be careful of that. NVT actually is one of the key parts to proving how come the plus c. But the nice thing is, we don't have to necessarily know proofs for AP.
Yeah.
But college professors might be quite impressed if you do know. So, if some of you guys are looking into going into pure math, not just applied math,
What do you do with a math degree?
you may want to, yeah, you can go anywhere with it. You may want to check out some of the proofs that our book shows, because they are interesting and they are helpful.
Should we write that
And again,
down?
you're reading at Cal Poly with honors, an honors math, applied math major. We'd probably say it would be helpful before book.
Should we write that down, the little highlight thing? Or we don't want to?
It's up to you.
Okay. Because you won't test us on it.
No,
It's not
I
necessarily
won't.
useful at all.
So then, number 2, what if I was to ask you something like, which function, let's just say find the antiderivative, yeah?
Yeah.
We're just finding the antiderivative, the process is called antidifferentiation, as you see up above.
That's a big word.
It is a big word. Find the antiderivative given f of x is equal to, let's have fun with it. How about 5x to the 3 house? Go. Now the nice thing is eventually as we get into integration, we'll have rules that we'll memorize and you remember and you'll do. But thinking through the process is where the work is. Have we been deriving too long, or can you guys think backwards? What power would x have?
I know.
And if we were taking a derivative, that 5 halves would come down, and we'd have to only be left with a 5, so what must be chilling then? 2. If you wanna think of it, you can say 5 times 2/5, which is just 2. And then we just add in a plus. So in section, go ahead.
Wouldn't it also be x to the 13 over 2?
Because it's,
Why?
because it's plus
Because
1.
Because if you were to bring up the 5, no, never mind, that makes no sense.
Maybe too much fun.
Yeah.
Yeah.
I'm curious where your mind is going.
Oh, I know where she's
am a
going.
little bit too, I don't really know.
Oh, I know where she's going, I figured it out. So you know when you bring down the n,
So I was thinking,
She
if you
thought
bring it
5.
back up.
but what she forgot was that there could have been
Oh.
something there that the n came down to and multiplied to equal 5, that's what she forgot. Psychology.
Mind boggling. Sam likes it. Just kidding. Talking about psychology. Poor Sam. Let's keep going. Section 5.3.
Oh, okay.
Now we'll do that tomorrow. Real quick before we leave section 5.2. Isn't there a special case to MBT?
Roll.
And what is that specific special case to MBT called? Rolls.
theorem.
And technically, Rolls' theorem came before MBT in that it was first proven that rolls could be true before we went to the general MBT could be true. So someone help me out. What is the helpfulness or what is the purpose of rolls and what does it help us quickly do?
Critical numbers?
If the beginning point equals the ending point, then it has
Meaning
to be
the
zero.
heights, right?
Yeah, heights are equal, then there has to be one point where it's 0.
Yeah, so it's a specific application in that if f of b equals f of a, that means that f of b minus f of a all over b minus a would be 0, hence there has to be a horizontal tangent line in between, hence the critical number in between.
Exactly between them?
No, somewhere between them. Remember, some C within A to B. This one is exactly between, but it doesn't necessarily mean it always is. Because Gerardo would us to give something like, for instance, this, no, I don't want to use a parabola. Stink, I need something else. Nope, I don't want that one either.
Oh, because it's not.
No, yeah, not gonna be equal. Nope, not that one either. I don't know, I need to think of something that wouldn't be exactly halfway in between, but I don't want to say it
Is it a
necessarily.
little W with the Oh wait, you can just change where A to B is. So you can draw a parabola and just make.
Yeah, but wherever they're equal, there's gonna be symmetry for a parabola, you know what I mean?
This is section 5.3, right?
So I can cut it in half.
This
and
is
that's
one
where
last
it's
thing
gonna-
on 5 too.
This is the one last thing in 5.3, not necessarily, it is a forever card, I just wanna do a quick little remember, MBT is the big one that we need to know for the AP for sure, but every now and then we can use rolls, which says, hey, if we can figure out that 2 y values are the same, then there must be a horizontal tangent somewhere in between. Okay, section 5.3. If you look at the section title, you will totally see why I did not realize they were gonna cover the first and second derivative test in this section. And to be honest, I'm not exactly sure how they expected you to do all of 5.1 without these tests. So we've already technically reviewed them, but we haven't written them down anywhere, we just kind of used them and said, hey, yeah, go, good.
What are you saying?
How do they expect us to do section 5.1 then?
Exactly.
Oh, maybe didn't they teach us in AB? Didn't they teach us in AB?
Oh, yes, an AB, but this is not a BC book, this is an ABBC book.
Really?
A little bit advanced ABBC book. So we're not gonna go in huge detail, but remember what's going on. First derivative test, F prime pitchfork it, yeah?
Oh, I have a question. When you're pitchforking it, do you say 0 at x equals blah 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 critical number, or if it's at the bottom, d and e at x equals blah 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 critical number?
Yeah, that's typically what I do.
Okay.
So you can check the domain,
And that'll be like, they'll be like, okay, he did this.
They just need to see you setting the derivative equal to 0, equal to d and e, and then showing what results. So you don't have to use a pitchfork, but you do have to show that you are finding zeros in the d and e's.
Okay.
And then if f prime changes from, oh no, we did write this, didn't we?
Yeah, I think we did.
What do we have?
Why?
George said.
We have increasing to decreasing of our function in some sort of sharp point or horizontal tangent line, so therefore we have a relative or local max. And then decreasing to increasing, whether a sharp point or horizontal tangent line, we have a relative or a local min. It's okay, never bad to keep reviewing. Second derivative test, we still have to technically think about the domain. We still have to find what?
Zeros?
Not enough.
Oh, no,
Pips.
yeah, pips.
Nope.
No pips?
No?
Oh, no, that's, never mind.
You find pips.
What do relative extreme come
Oh my gosh.
Concavity?
No.
Well,
Well,
it's
we
positive.
We do test concavity, but we test concavity where? For relative extrema,
At critical numbers?
at critical numbers.
Aren't they called pips?
No.
No,
That's,
critical numbers still of the original, just F prime. Pips are helping us separate concavities. We're not trying to do a sign chart for concavity. It's just reminding how do you use concavity to help us out with finding relative extrema. So we can plug, we'll say C is or are the critical numbers of F, aka the zeros or d&e of the derivative where F exists. So if F double prime of C is greater than 0, then I have a concave up like a cup, and who is that?
critical.
Relative min. My concavity is positive at a critical number. If my concavity is negative at a number, concave down like a frown at that point, which will be a relative max. And as we talked about earlier, if the second derivative is 0 or does not exist,
Fails.
it must not be curved at that critical point. So therefore, I can't use concavity to help me determine. I say the test fails and I go back and just put a normal sign.
Wait a minute.
So then all of this reminds us that we have not yet reviewed concavity or points of inflection. And then we have to talk about, ooh, what if we're given a graph of a derivative or a second derivative and then a little bit of motion and we're done. So basically, guys, section 5.3, I'm trying to show you this because some of you would rather do homework tonight, more tonight than more over the weekend. Section 5.3 starts with 5.1.
So,
Sign
That's weird that
charts.
they didn't teach us this first.
Right? That's what I thought.
Okay.
And when I looked at the section title, I totally thought it was just graphing, right? Like connecting with the graph, but no.
Wait, so Miss Steve,
Anyways.
does that mean